All right, our next type of graph to learn about is circle graphs. So, circle graphs are an easy way to display part to whole and part to part relationships. Each portion of the circle is going to be a percentage out of 100, and the entire circle always adds up to 100%. So if you have a circle graph question, you can pretty much bet and guarantee you're going to be using a proportion because percentages are involved. Okay, so the next section says to use the information below to complete the table, answer questions, and then look at the circle graph. So this is an example of a circle graph. It's kind of similar to a bar graph where it's broken down into categories, but each category is assigned a percentage. Now, the percentages are missing out of this one because they're asking you to find them here. So we have the number of students that are in each category. So we need to add those and get a total, like always. So 16 for sports, 8 student council, 4 debate, 9 music, 13 none makes 50 total. Okay, so if I wanted to know what percent of students played sports, my proportion would be 16 out of 50 x over 100. And this one does have a shortcut. 50 times 2 makes 100. 16 times 2 makes 32%. And I'm also going to label that in my circle graph. Sports is 32%. Okay, student council, we would do the same thing. There's 8 in student council out of 50 total. So to turn that into a percent, we do x out of 100. Shortcut times 2 times 2, it is 16%. Debate has 4 students, so it would be 4 out of 50, x over 100. Shortcut times 2 times 2 is 8%. Music has 9 out of 50. Shortcut times 2 times 2 is 18%. And then lastly, music is 13. None is 13. Shortcut times 2 times 2, 26%. A says to explain how the size of each portion of the circle corresponds with the percent of students. Similar to what we said with bar graphs, the largest bar has the most amount and the smallest bar has the least amount. Same thing is true with a circle graph. The larger piece of the circle graph that it is, the higher the percentage will be, versus the smaller piece of the circle graph, the smaller the percentage will be. Okay, so the largest percent equals the largest part of the circle, and the smallest percent, oh, my pen is running out. The smallest percent is the smallest part of the circle. B says, if the circle graph was complete with percentages, how could you determine the number of students in each elective? What information would you need to know? So basically they're asking, what if this was the opposite of what we were given? What if we just knew that there were 16 students in sports and we had the percentage, and we knew that there were 6 8 students in student council, and we knew that that was 16%. How would we then be able to figure out the students in each elective? Well, that would shift our proportion around, because if I had the percentage, that would go on top of 100. So that means we would have to be able to know the total of students to figure out how many is in each elective. So X can go in any spot in our proportion. If we need a percent, it goes over 100. If we're looking for the part, it goes on top. But if we're looking for the total, it goes on the bottom. It just depends on what you're being asked to figure out. Okay, so we have an example of that down here at the bottom. The student council at North Middle School held an election for student council president. The data was displayed in a circle graph. So you have your election results. You can see each person and the percentage of votes that they received. A says, if 280 students voted for Morris, then how many students participated in the election? So this is a circle graph, meaning we're going to need a proportion. Morris received 35% of the votes. And then they said that he received 280 of those votes. 280 is Morris. That is not how many total students were in the election. So that 280 is the part. We do not know how many students voted. Cross multiply, we have 35x and 28,000. Divide by 35. $35 will not go into 2 or 28, but it does make 280 8 times exactly. Then we bring a 0 down, bring it up, bring a 0 down, bring it up. There were 800 students that participated in the election. B says, what if 600 students participated in the election? Then how many votes did Suarez receive? So we need a proportion again. Suarez received 40% of the votes, so 40 out of 100. This time they told us the total. 600 students participated. I don't know how many of the votes went to Suarez. So we cross multiply 100x. 6 times 4 is 24, and then we have 3 zeros with it. Divide by 100. Take out your zeros. And Suarez received 240 votes. All right, next set says the 6th grade students participated in a fitness challenge through their PE class. They chose an activity and committed to that exercise 3 times in 1 week. There are 250 6th grade students. Use the graph to determine about how many students participated in lifting weights, running, and swimming. So 250 is our total. I want to know how many students were lifting weights. Proportion, lifting weights is 8% out of the total. And then there were 250 6th graders. I want to know how many were weightlifters. Cross multiply, we have 100x. Cross multiply, 25 times 8 is 200. And then I'm going to add an extra 0. Divide by 100. Take out your zeros. And x is equal to 20. We know that there are 20 students that lift weights. Next up, we want running. Same thing. Now we look at running. Running is 30% out of 100. And we have X out of 250 students. Cross multiply, we have 100X. Cross multiply, 25 times 3 is 75. And then we add 2 zeros. Divide by 100. Take out your zeros. And X is 75. We know there are 75 students involved in running. And then the last one is swimming. Swimming is 5%. So 5 out of 100. X over 250. Cross multiply, we have 100X. 25 times 5 is 125 with an extra 0. Divide by 100. We can take out 1 0, but then we have 125 divided by 10. 10 will not go into 1, but it goes into 12 once. With 2 left. 10 into 25 goes twice for 20. With 5 left. Decimal, 0. 10 into 50, 5 times. But remember, we're talking about students here. I can't have 0.5 students, so it's going to round up to 13. Okay. Next one, part B, says Joseph says that the number of students who chose swimming, walking, and lifting weights is greater than the number who chose running. Explain why you agree or disagree with Joseph. So, if we look, swimming is 5%, walking is 17%, lifting weights is 8%. If we add those together, we get 30. And they're saying that that is greater than the number of students who chose running. Well, if we look, running is also 30%. So that means Joseph is incorrect. We disagree. And we disagree with him because they are equal amounts. Those 3 categories combined made 30, and running is also 30. Okay, last circle graph. Jonah created a monthly budget to keep him on track financially. He categorized all his expenses and represented them in the circle graph below. So we have a circle graph, and there's percentages missing. So this says to determine if the following statements are true or false. Jonah spends over 50% of his income on housing and utilities. So 50% is half. Okay, so that means if I cut my circle in half, that it would be housing plus utilities. That is going to be false, okay, because 50% is housing and food, but utilities is way smaller than the food section is. The next one, Jonah spends less than 25% of his income on transportation and utilities. 25% is the same thing as 1/4. So if I cut my circle into fourths, that should be for transportation and utilities. Okay? But if I were to cut my circle into 4, that pie wedge would be about this size here. And utilities is just under that line. So this one is going to be true because it's less than 25%. The next one, Jonah spends about 1/3 of his income on transportation, utilities, and spending. So 1/3 means I want to break my circle into 3 parts. So now we're looking at transportation, utilities, and spending. Okay? And we don't know for sure, but it does say the word about. So if I were to cut this circle into 3 pieces, that means the other one would come out this way, and those are about the same size. So these 3 pieces together That is true. That is about 1/3 of the circle, even though I don't know the exact percentages. Okay, the last one says Jonah's income is $3,000 per month. He is able to save $600 per month. Use that info to determine the percent of money that he saves. And then we are not going to do this last statement because you're not going to be asked to do that. Okay, so we know he makes $3,000 a month. 600 of that goes to savings. I want to know what percentage it is because our percents are missing over here. So if we do our proportion, my percentage is missing, so it's going to be X over 100. 3,000 is his total income, and then 600 of that goes to savings. So we cross multiply, 3,000 X. Cross multiply, we have 600 with 2 more zeros. Divide by 3,000 on both sides. We can take out 1, 2, 3 zeros. So now we just have 60 divided by 3, which makes 20. So X is equal to 20%.